Good morning. All right, we have a little bit kind of a long lesson today. We're going to be talking about circles. And measuring circles, we're going to be on section 17.3 in your book. So if you'll make sure and have that out, and you'll also want to have worksheet 17.3 close by. And thankfully, even though the lesson's long, the worksheet seems to be a little short. Okay, finally time to explore measuring the ever-handy circle. While you may already know some of this information, I think you'll find some interesting new tidbits too. First off, let's review what a circle is. Okay, another way to think of a circle is as the set of points in a plane that are equidistant from a given point. You have the center from one side of the other, or one side to the other side, across the middle, across the center, is called the diameter. And then half of that is the radius, and the length around the circle is the circumference. Now, I find circles quite interesting, and you'll find out why here in just a second. Now, because the circle is so unique and useful in describing different aspects of creation, we have different terms to help us describe the parts of a circle. And I just described those for you. Now, and at the top of 339, it shows you the radius. It's the distance from the center of a circle to one edge. So from here to here or here to here. Basically, the radius is a slice of pie compared to the diameter. Actually, my slice might be cut about right here, and then that would be my slice. But that's another story for another day. So the diameter will always equal 2 times the radius. And the radius will always equal half the diameter. So if you'll look there on page 339, the diameter equals 2 times the radius, or there's a formula, D equals 2 times R. The radius equals half the diameter. You can use this to help you find the radius when you know the diameter, and the diameter when you know the radius. For example, if the diameter is 4 inches, the radius will be 2, because it's 4 divided by half. Okay, so with those terms in your tool belt, let's learn how to find the perimeter, which actually is called the circumference. So you don't find perimeter of a circle, you find the circumference of it. And we can also find the area of circles. Now, let me click back over here. I may come back to this. In fact, you may want to jot this down in your notes if you want to, or print it out, or whatever you want to do, using the different colors so that you can remember, you know, what all the little pieces are if you want to. All right, so let's go back here. Now, how can we find a circle's circumference, or the distance around a circle? We can't exactly use a ruler since a circle doesn't have straight edges. But if we could stretch the circle into a line, we could then measure the distance. Now, this is telling us to do this ourselves, and you can if you want to. If you want to get some string or something like that, you can do this. Now, it says, take a piece of string or yarn and use it to outline the circles below, which are fixing to be on the next page. So here are these steps. You're going to lay the string or the yarn around each circle, cutting it so it just fits around the circumference. Now that's going to be kind of hard because string doesn't tend to lay, flat. You might need to use a piece of tape, but I still don't see how that's going to help. But nonetheless, measure each string with a ruler in millimeters. That length is the circumference, or the distance around the circle. And it says be sure to write down the measurement for the circle. Now, it gives us the measurements here, so that's why we don't have to do it. So if you'll turn the page and look at 340, these are the 3 circles that they're talking about. And at the back on page 339 at the bottom, it tells you the measurements. The first one is 132 millimeters. The middle one then is 97 millimeters, and 162 millimeters is the bigger one. Now that means what they did again is they took some string and they put it exactly around it to where it just fit around it perfectly, and then they stretched the string out on a ruler and measured it in millimeters. Now, there is a way to find the circumference using math instead of a string. To do so, we need to find the exact relationship between the circumference and some other part of the circle that we can easily measure. So let's try seeing if there's a relationship between the circumference and its diameter. And there is. And this is what I find interesting. So it says measure the diameters of the circles above in millimeters. Okay, so the diameter is that straight line that goes across each circle. Okay, remember the diameter goes from one side to the other through the center. Okay, so they've measured around the outside, the circumference of each. Now they've measured the diameter. Now, number 4, right in the middle of your page says, find the ratio between the circumference and the diameter by dividing the circumference you found in step 2 by the diameter found for that circle in step 3. So right quick, let me show you this. Okay, so I'm just going to, just for the heck of it, just show you this. So we're gonna take that very first one. All right, let me move this little doohickey right here. There's our little diameter. All right, so remember the circumference of this one was 132 millimeters. Now remember, the circumference is the measurement around it. Okay? And then see here, they measured the diameter of this one as being 42 millimeters. Now, it says, let's find something in common. So it says to take these two and divide. So let's just do that. Why do I have a scientific calculator? I wondered why it looked so funny yesterday, or whenever I was doing it. All right, so we're going to take 132, we're going to divide that by 42. Okay, note this number, 3.14. I can't write it down because if I do, my calculator will go down there. 3.142857142857143143, blah, blah, and it continues to go. All right, note that number. All right, now the next one, I'm not going to draw it, but the one in the middle, that little one, its circumference was 97. Let me pull this up. Its circumference was 97, and its diameter was, what was that middle one? 31. Let's see what that ratio equals. 3.129032258, blah, 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 blah. Okay. Very close to this other one, wasn't it? Okay. Now let's do the last one. So we have the circumference of the big one was 162 millimeters. We're going to divide that by the diameter, which was 52. How much do you want to think it's 3 point something? Looky there. Now, did you notice that all three of those, when we did the ratio, we divided those numbers, the circumference and the diameter, and on each one of those we got 3 point something something. Now, let's start reading there where it says step 4. While you weren't able to get precise measurements, even the rough ones you took should show that the circumference of a circle is roughly 3 times the diameter. So on one we got 3.14, on one we got 3.11, I think one we got 3.12. So if you just figure the average, the circle, those 3 circles, the circumference is about 3 times the diameter. Now that is true for every circle ever that has ever existed. The circumference is approximately 3 times the diameter. Now let's read a little bit of history here. The Greek mathematician Archimedes used triangles, a polygon, angles, and more to help him more accurately find the ratio between the circumference of a circle and its diameter. The picture is one used in his proof. He concluded the ratio was less than 3 1/7, but greater than 3 10/17. So there's half of a circle right there, and see how he's used triangles and he's doing all those fancy measurements. Now there are complicated formulas and processes used to try to compute the ratio between a circle's a circle's circumference and its diameter. But all those attempts fall short, though, to fully express the ratio. The actual ratio can't be quantified. It's a number that keeps going on and on and on indefinitely. You notice those numbers were just, they would keep going. In other words, the ratio is the ratio between this and this is so precise that you could keep calculating it forever without finding an end. I'm at the top of 341. It begins like this, and here's our number. 3.14159, blah, 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 blah. And you see those three dots there, meaning, and it goes on and on. Okay, today we call this number pi. It's pronounced pi, spelled this way. Okay, now the symbol that we use for pi that's my drawing of it. Okay, so this is this. Okay, it's just a symbol. And this equals so pi is the representation of the ratio between every circle's circumference and diameter. Now tell me we don't worship a great and living God who has made everything so perfect. Just take a look at this circle. And every circle's circumference and diameter, the ratio will come out to be somewhere right at 3.14. Now, because we know God is keeping all things together consistently, and we know the ratio between the circumference and the diameter of a circle, we can apply that knowledge to help us find the circumference of any circle. We know that if we divide the circumference by the diameter, we get the ratio between the two, which we just saw was pi. So if we multiply the diameter by pi, we'll find the circumference. So in conclusion, to find the circumference of any circle, we just multiply the diameter of the circle by pi. Or, since the radius of a circle is half the diameter, we could find the circumference by multiplying the radius by 2, thus finding the diameter, and then multiplying that by pi. So don't be confused about all of these terms and numbers and symbols and such. We're going to practice a lot with these. So, to find the circumference of a circle. And this is right there in the middle of your page on 341. Okay, these are your formulas. The circumference of a circle equals pi times diameter. You might want to jot that down or make a note of it somewhere. 2 times pi times the radius. One of those two. Depends on if you're given the diameter, if you're given the radius. So there you go. It's kind of written out. You see the different ways that you can use it. Okay, it's always been, has pi always been expressed this way? No, it has not been. It's just, I think over the last several hundred years, man just gave this symbol to mean pi, and I think it's a Greek symbol. It is. It's the Greek letter P, apparently. So let's look at this first example at the bottom of 341. Now it says, find the circumference of a circle with a diameter of 81 feet. Remember, always write your formula first. So find the circumference, so that means it's going to be circumference equals, and they gave us the diameter, so that means it's going to be pi times diameter. You can write it that way if you want to. Then you're going to fill in your numbers. 3.14 this is always 3.14. Times, and it says the diameter was, what was it? 81 feet. So then, of course, on your calculator, you're going to calculate 3.14 times 81. You're going to get 254.34. And that's where they put there. And that's feet. Now, it's not square feet because you're not going to measure a circle using squares. Okay, so there's another example right there at the bottom of 341, and on this one it just gives you the radius. So remember the radius, you have to multiply it by 2 in order to get the diameter. So your formula would be a little bit different. It says to find the circumference of a circle with a radius of 20 feet. So our formula for this is going to be 2 pi r. Now I didn't use the dots, but you can. But 2 pi r to me just seems easier to remember. You can put the symbols and the letters beside each other. That indicates multiplication. So then you're going to plug in your numbers. 2. Now here you're going to want to put your dots because in here you're using numbers. Pi is 3.14. And then it told us the radius then was 20 feet. And then you're going to calculate all that up, and it comes out to be 125.6 feet. If you'll turn the page. Now it says finding the area of a circle. Now we know how to find the circumference of a circle. Let's take a look at how to find the area or the space inside. The circumference, of course, is like the perimeter, but we don't call it that on a circle. So once again, we need a way to relate the area to some other part of a circle that we can measure. And once again, the work's been done for us. The lengthy process of subdividing the area of the circle into other shapes has already been done, so you won't have to repeat it. So below is the formula for finding the area of a circle. So here it is. Area of a circle is pi times radius times radius. This can be abbreviated to A equals pi r squared. Let me get a new screen on here. So area of a circle is 2 pi, no, I'm sorry. It is pi, which is 3.14, r, which is radius, squared radius. Now we can use this knowledge of how the area of a circle relates to its radius to find the area of any circle. So the area of a circle with a diameter of 6 feet. Look right below this circle. Since we only know how the area of a circle relates to its radius, not the diameter, we have to first divide the diameter by 2. So you're going to find half of it. So to find the radius, in this case 3 feet, you can use the formula radius equals half, which a lot of times you'll just be able to look at the radius and you'll know what half of it is. But basically, when it gives you the diameter but you need the radius, just take the diameter and half it. That's all you have to do. So now we've got our formula. We've already figured that it gives us the diameter, but we need the radius, which we know is 3. So then you're just going to plug in your numbers. Pi, which is 3.14, times 3 squared, 3 feet squared. And remember, you got to square the 3 feet first, which would be 9, because 3 times 3, and then multiply that by 3.14, and you get 28.26 square feet. Now remember, it is square feet because we're doing area, okay? So not that you're actually, I mean, you are using squares to fill this in, but because it's a circle, you know, you're not going to have perfectly good squares. That's why I said that a while ago. Okay, keeping perspective. Today we explored the ratio between diameter and or radius and the circumference, the perimeter kind of a circle. Discovered the circumference is a little over 3 times the diameter, but that the actual ratio is a number called pi. It goes on and on and on and on and on. We then applied that knowledge to finding the circumference and the area of circles. We'll learn more about pi in the next lesson, but for now, we're going to have fun doing some real life exercises in our student workbook. So if you will look at section worksheet 17.3. Now it has 1, 2, and 3 that you can use your calculator with. Okay, so in part 1, it wants you to find the circumference. Remember, circumference kind of goes along with perimeter. That's what it is. It's the outside of your circle. So to find the circumference of the circles given, you're going to want to know there are 2 formulas you need to know. You need to remember. Remember if it gives you the radius or it gives you the diameter. And that's over there on page 340 through 1. So it's either going to be C equals pi d or C equals 2 pi r. Depends on what you're given. So on number 1A, you're given the diameter. 1B, you're given the radius. And 1C, you're given the diameter. Pardon me. So on 1A, you're going to use the formula C equals pi d. Fill your numbers in. Circumference is just like perimeter, so you do not square it. All right, and then on 1B, you're going to use the other one because they give you different information. It's pi I'm sorry, it's 2 pi r. Fill in your numbers. And then, of course, on 1c, you'll go back and use this one. Now, on area, which is number 2, the area that you're going to, oh my goodness, I can't spit it out. The formula that you're going to use there is going to be this one. Area equals pi r squared. It's going to be kind of hard to keep those, you know, situated in your mind. But anyway, okay, so then on part 3, you're going to use what you know about perimeter or circumference and area and answer those questions. Make sure you use the correct formula. And then on the back of the page, it's mostly just skill sharpening. You should do well on that. All right, so let me know if you need any help.